a Thanksgiving special from Dr. White. And hopefully, I won't be a turkey today. Gobble, gobble. Oh, is that awful? I'm glad I'm cutting it out of the video. All right, everybody. Good afternoon. It's time for some more exciting organic chemistry with your host, me, Dr. White. Now, as you know, or if you didn't, I'll tell you now, excuse me, Monday, I was having a lot of internet problems and I got bounced off a couple of times. I just posted the video. It took me a long time to process it because I lost about 10, 15 minutes maybe. I'm not sure, but I'll recover that stuff today because we're ahead of schedule, which is good. Let me do one thing. Uh, Anyways, so uh, I called my internet company. They were pretty good. Traced it down to I don't know if you call it a loose cable or bad connection in a splitter I have downstairs in my basement where the cable comes in. I split it to my TV and up here to my modem. And that seems to fix the problem. And I got some parts in over the holiday. I'm going to try working on getting the clicking out of the way. Will it work or not? I don't know. All right. But before I forget, I'd like to wish all of you a happy Thanksgiving. Hopefully, it's a safe one. I'm staying home. Yesterday, when I went out for my physical therapy, I also did some shopping, normal shopping. The local store I go to, Valley Produce, which is wonderful, gives senior discount on Tuesday, 10%. If you haven't noticed, I'm not a spring chicken. Or, I guess, a fall turkey. But enough of that. Oh, on another good note, my back is back to about 95%. I've been busy the last 2 days playing with the videos and all that. Like I said, I just uploaded Monday's lectures. But by Friday, make it Saturday, I'll have all your labs that you've handed and graded and in D2L. Another thing that I should mention, I believe it's a week from today, will be test 4. By Saturday, I will have sent out an email and posted in D2L the points breakdown, what's covered on test 4. There'll be fats and oils, and it will also be carbohydrates, just that. Uh, and on Monday, I'll go through the carbohydrate practice problem answers, problem set, because I've already finished it. We're just going to go over stuff today, and then we'll do a lab. I'll let you out early. It's holiday. If we were at ECC, half the class wouldn't show up. Why they don't close Wednesday? Nah, nobody asked me. All right. Any questions before I proceed? Again, have a healthy and safe Thanksgiving. I'm not going to make a whole turkey just for myself. I have in years past. I got lazy, but I got the important things. I got the cranberry sauce in a can. That's traditional. And I also got what's our family favorite. And at Valley, they sell them separately. And that's the turkey tail. I think I talked about, did I teach you the word pupik yet? All right, Yiddish time, and we got enough time today because I'm letting you out early. But how many of you are familiar with the tail on a turkey? Part that went over the fence last. In Yiddish, your rear end, there's two words that define it. One's becoming an English word, that's tush. That's really a Yiddish word. And the other one is pupik. And in our house, our family, from the time I was little for whatever, there was always great wars over how much of the pupuk do you get, because that was the prized part, that and the skin. The rest of it's okay, but the skin, turkey skin, and the pupuk were fought over until a number of years ago we had a mutual agreement treaty how to divide everything equally so nobody gets upset. And that was a great advancement because everybody wasn't upset now. But I digress. Have a happy Thanksgiving. Let's get to work. All right. Since I might have missed a few things in the video from Monday, and review is good for your grade, I'm going to go over some stuff you should know. And let's get going. Now, I'm going to draw it this way. Sometimes my software will do this. And you should know that in math, 3 lines means identical. And when I taught you, here's one way of writing an aldehyde, here's another. And you should know this equilibrium. And what happens is, well, the general reaction, as you learn in as you learned in test 2, if you take an aldehyde or ketone, react it with an alcohol, and since it's between 2 molecules intermolecular, you need an acid catalyst. And now what you get, keep your eye on the carbonyl, because that's where the fun is. What's attached to the carbonyl is there, becomes an alcohol, and this part is bonded to the carbonyl carbon. Well, here's our carbonyl carbon, here's our alcohol. And just like this attacks and forms this bond, we're going to form a new bond between this oxygen and this carbonyl carbon and open this up to an alcohol. What's not involved in the reaction, I just rewrite. This is coming along for the ride, and it does. The change, this carbon, which is this carbon, still has the hydrogen, that's R prime. It will have a hydroxyl group, this right here, and then this oxygen will be bonded to that carbon, just like this oxygen is bonded to this carbon. And you should know how to do that. Again, this hydroxyl group, and by the way, this is C5, carbonyls 1, 2, 3, 4, 5. And remember, each intersection of a line is a carbon, and it bonds to the carbonyl, opens it up to this hydroxyl group, and it's a hemiacetal. And if I give you this plus this, you should know how to write this. If I give you this plus this, you should know how to go backwards to do that. So you're writing it down, so I'll wait until you're finished. All right, the next one, which Dr. White always forgets the structure, so I'm going to cheat and look it up. Oh, by the way, the sugar I started before, let me finish this structure first. Don't forget there's a carbon there. This is, and I should have mentioned, glucose. And so is this. Hold on. Know how you have a bad hair day? I think I'm having a bad arrow day. And this is also glucose. It's a cyclic form, or it's also called the hemiacetal form. Now, this is fructose. And if you look at the reason I'm mentioning this, if you look at the problem set for carbohydrates, some of the problems which are new type description give the structure or give the name of the product or the starting material, depending on this. So here we have fructose. It's in equilibrium. Again, same reaction. I'll rewrite how you learned it for test 2. Now, when it's between two molecules, you need the acid catalyst. Keep your eye on the carbonyl. This attacks that, the oxygen actually. And here's that carbon. Well, if we look over here, again, C5 hydroxyl group is this alcohol. This carbon is this R group. It just so happens it's attached to R double prime in the backbone here, but this now attacks the carbonyl carbon, like right here, and whatever is not involved in the reaction, I'm just going to rewrite because it comes along for the ride. Now, this hydroxyl group is this oxygen, which is this oxygen, which is bonded to my carbonyl carbon, which is no longer. And this is a chemical bond. Here I'm just showing how it's going to act, but this actually, and the one above, is a bond. And if you don't draw that in, it's wrong. And this also becomes the hydroxyl group there. And you should know, if I give you this in the equilibrium, you should know how to draw this. If I give you this in the equilibrium, you should know how to draw this, or maybe give the name if I allow you to do that. And that's an important thing. Oh, good news, since I'm not going to lose internet. Oh, shucks, I shouldn't have said that. Hold on. I think I rectified the problem. But anyways, I'll be posting this on the video later today or tomorrow, because I got my Chem 112 videos, or not 112, 1211 to post. So this might be posted sometime tomorrow. Yes, I will work tomorrow. I've got stuff to do. But I'll also have fun too. I'll probably be on Zoom with family and also some friends of mine. So that will be nice. All right. I'll only do 2 of them, where Monday I did 4. And this you do not have to write down. Oops, made a mistake. I should have done this first. All right. Now, one of the things I taught you new was if you have a hemiacetal, you can react this with more alcohol, acid catalyst, and this is an unsymmetrical acetal or ketal. And I showed you this on Monday, and we did, and I'll do another reaction when we're done with this reaction. But if you look here, this right here is this right here. And if we look here, this is an alcohol, which is this alcohol. And this reacts with this, replaces the hydroxyl group with OR triple prime. Well, in this case, this oxygen, I'll use different color, but still chemical bond, is bonded there, and you don't have to write this down. And that forms this new bond right here. And if you notice up here, I have another acid, hemiacetal, that I can react with more glucose, and keep on going and going. And what this really shows you is a couple things, that glucose can be bonded together with itself many times. And when this is large, like 50 or more, I think that's the cutoff. Can't spell either. We call that starch. And what's the linkage between here? An acetal. Therefore, you learn for test number 2, you take an acetal or ketal, if H, R prime is H like in glucose, it's an acetal, and you get back to ketone or aldehyde that you would have used to make this, plus the alcohol you would have used. Well, in this case, for starch, first of all, the previous one, if I take 50 glucose and react it with a lot more glucose with an acid catalyst, you get starch or carbohydrate, cellulose, you get carbohydrate or polyglucoside as it's called. Now, once again, Dr. White can't spell. That's been my curse my whole life. Just I can't spell. Now, what this also implies is if you take starch and react it with water and acid, like in your stomach, you'll get glucose back together. Because in glucose, you have your alcohol and your aldehyde when you break it down right here. These are connected together in glucose. Now, another thing I taught you, which I'd like to review, you should know sucrose is the chemical common name for what you call sugar or table sugar. And what that's made up of is a glucose bonded to a fructose molecule. And this also is an acetal linkage. Therefore, first of all, you add water and acid. You know something? I've been hogging all the fun. It's your turn. What's the product or products? You can either draw it or give the name when you react sucrose with acid and water. Samantha, does Pinky get any turkey?
I have tried in years past, but she won't eat treats. She's too picky.
Oh, what's her favorite? Shrimp
She
or
won't eat any treats.
what kind of food does she eat?
She eats Origin. It's a cat food called Origin, and then she eats it's a dry food, and then Tiki Cat wet food. It's the only stuff she'll eat.
Oh, very picky.
Oh yeah.
You haven't tried
No,
giving your filet mignon, have you?
no, she wouldn't get that even if she would eat it.
I'm kidding. Yeah, right. Give it to a dog too. Yeah, right. Even though my sister, if we were eating stuff like that, would. I don't know if I told you over the years, my sister has always had many dogs in her house. In fact, because my parents, mainly my mother, would never let us have a dog, and my sister always wanted it. The guy she married, they both agreed. Within a month after they got married, she got her first dog. And he loved dogs too. And at one point, they had 5 sheepdog in their house. That was amazing. And then later on, it became mixture sheepdogs and border collies. Then it became all border collies. And then it became border collies and papillons because they were smaller dogs, even though I don't like the papillon she had. I did everything I could not to slam it against the wall. And I love dogs, but this dog was nasty. Anyways, back to better things. What do you get when you consume sucrose? And I could have, instead of this, I could have put sucrose. I could have also put, and the answer is glucose plus fructose. And that would be the same thing here, obviously. All right. Now, one of the ramifications of this general reaction, because starch, which is this, and the acetal linkages, you should know how to describe with words and a general reaction what happens in your stomach when you eat a carbohydrate. And the first thing is in your stomach, phone is ringing. 3 more rings and it'll stop. I was wrong. It didn't too. They gave up. If I don't know the number and my Bluetooth phone from my cell phone, I have all the numbers of people I know who would call me. And if I don't know it, guess what? You get my answering machine or answering on my cell phone, and I can pick up the voicemail if it's that important. Meanwhile, what happens in your stomach when you eat a carbohydrate. In your stomach is acid and water, and therefore you have acid hydrolysis. What's the linkage or bond between the glucoses and acetal? And the general reaction acetal or ketal, if R prime is H, it's an acetal. And you learn this for test number 2. You get back the aldehyde or ketone plus the alcohol you would have used to make that acetal. In this case, they're connected together in glucose when you break that down. Now we're in this, wait, I'll give you a chance to write this down. And you should know this. Hint, hint, double hint. It's amazing when I do something like that, everybody starts writing it down, which is a good thing. One nice thing when you guys have your video camera on, I can tell when you're done writing. Take your time. Also, if you don't get something, you always go back to the video too, but all right, let's move on. While we're in this neighborhood, another thing you should know how to describe with words and a general reaction, what happens when you eat a fat or oil or something that contains it. And what's the functional group in a fat or oil? An ester. You should know that. And in your stomach, there's acid and water. So this is acid hydrolysis of an ester. And for test 3, you learned if you had an ester, react it with acid and water, you get back the carboxylic acid plus the alcohol you would have used to make that ester. And you should know both of these. And so you should know when you eat a fat or oil or something that has that in there, like if you're having turkey tail, there's a lot of fat in it. That's what makes them so good. Plus, there's a lot of skin around it. It's nice and crunchy. Oh my God, Dr. White's being sidetracked by the good stuff. I wasn't kidding. We had some major wars in our family till we came to a treaty. I mean, major, high school. Ooh. Anyways, you get acid hydrolysis of an ester, and here's the general reaction. Now, I'll wait until everybody gets that down. Now, I promised where I had the reaction of an acetal with an alcohol. And why don't you try this one for your fun and enjoyment? But to help you out, before you do this, hang in there. Quick, write this reaction down. It'll help you. Oh, Dr. White's being lazy. Hang in there. Must be a holiday coming up. Dr. White gets super lazy around holidays. And this is where you take an acetal or ketal and make it into an hemiacetal, hemiketal, and make it into an unsymmetrical. This carbon becomes this carbon. And all you're doing is replacing the OH with OR triple prime. And now I'll let you do that problem. Now, I was thinking of earlier, that's real scary. You know how people on TV and their medical experts are warning about Thanksgiving and how it can be a super spreader. I was just thinking, how many people are going to Black Friday sales, like in Walmart, Staples? In years past, when I was younger, I went there, and once they switched to online, why am I going to go wait in a crowd when if I want something, I can get it online? Which last Black Friday, I needed a new vacuum, and I got one from Walmart instead of going to Walmart near my house and waiting in a crowd at 6 in the morning or 5 and fight to get them. You know, I went online 7 o'clock Friday morning, bought the thing, had it delivered free of charge to my front door about a week later, and I was happy. I got a Hoover. I've always used Hoover, and it wasn't the most fancy one, but it does the job, and I'm happy with it. All right, let's do this. What's different? Ooh, 2 oxygens to the same carbon, which is this. What's this? Carbon, 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 hydroxy. This is an alcohol. And this is my R triple prime. Now this tells you the only thing that changes is the hydroxyl group here to this. So I'm going to write all the rest of it the same. The only thing that changes is OH becomes OR triple prime. The carbon with the hydroxyl group is the carbon that has the oxygen here. And as you know, there are 4 bonds to carbon, and you don't break carbon-carbon single bonds. And that's how you do it. Now, in starches, this up here, R triple prime, is another glucose molecule, which I showed you earlier. And why don't you do this one? And why don't you try this one? Draw the enantiomer of that molecule. All right, raise your hand if you forgot what enantiomer means. Go like this. It means the mirror image. Don't tell anybody it helped. think you've all heard the joke, why did the chicken cross the road? They have any turkey jokes like that? Why did the turkey cross the road? Those would be real gobblers. All right, looks like everybody's done. How do you draw the mirror image? Well, Dr. White likes to put it in his mirror. You don't have to. And now, achiral carbons, those with either a double bond or two or more hydrogens, you don't have to. If you wanted to draw this like this, that's okay too. Same thing with the aldehyde. You can draw it as a mirror image, but it's achiral. But these carbons, each intersection, so what's closest to the mirror here? Hydrogen. What's farthest away? Hydroxyl group. What's closest here? Hydroxyl group. Farthest away, hydrogen. Hydroxyl group close to the mirror. Farthest away, hydrogen. And the last one. And there you go. And that's how you do it. Next thing I'd ask you is, if you had a pair of pants on that had a button in the front and a zipper in the front and pockets, is that pants chiral or achiral? And the answer is chiral, because it has a right and left pant leg. And as soon as you can assign something right or left to an object, or it has it in its name, you know it's chiral. Chiral non-superimposable mirror image. All right. I'm going to do something different so I can let you out real early today. Instead of taking a break and coming back 5 minutes, I'm going to go right through. I think you're tough enough to do it. I'll get you out in about 15 minutes, and then you'll be able to go do whatever you're going to do the rest of the day. Hopefully study some organic. Right. But anyways, let's talk about today's lab. Now, Dr. White said, why? Because this is one of the most fun labs you could do, but you're not, well, you can do some of it at home if you'd like, but we're in the lab, you'd see me with a camera, and Dr. White and the camera are a bad mixture because I go berserk. My camera has a real big flash drive in it, so I can take 500 pictures. And in this lab, I take about 300, but click, click, I got all of you. But when I inherited Chem 170, the labs were awful, and I rewrote them all myself. The reason I had to rewrite them is if we were in the classroom or at ECC, if you look at the schedule normally, the lab is only an hour and 50 minutes. Most organic are usually 2 hours and 50 minutes, and most organic lab books are dedicated or predicated on the student has two and a half hours to do the lab. Well, my students never did, so that's why I had to write it. After I wrote a bunch of them, which you've already done, I said to myself, which I like to do, all right, let's do a really special lab that gives people the feel of if they were really in the chemical industry, but it's got to be a really lot of fun. It's got to be really educational. And then I put another thing on there that I challenged myself. It has to deal in an area I'm an expert. And plus the last challenge, which ECC made, it's got to be dirt cheap. And that's how I created the Developing Competitive Products Lab. Now, in the chemical world, or in just a real competitive world, people who make things from chemicals, you'll look at your competitor and find out what are they doing? Are they doing something we're not? And if they are, you can get a sample of their product, not from them, but there are ways of secretly getting it. And you analyze it, find out what it is, and you try and make a product as good or better so you can get the business and make money. Well, today, you're all my research group, because when I was in industry, I was a research and development manager after my first 2 years as a bench chemist. I rose up because the things I solved and everything, and I was given that positions. As I went on at other companies, when I left one company, I went to another company, and I had that side of position or higher. And what that meant is I had a bunch of chemists, PhD chemists, master's degrees, bachelor, and some technicians who reported to me. And my job, which a lot of chemists never realized, was to help company make money. And how do we do that? We made new products, or we solve problems for the customer or our own plant problems. That was an expertise I have. So in real life, I'd go to a chemist or some of my chemists and say, all right, we got a project I want you to work on. And how would I know what project? Well, I'd be in constant communication with the vice president of marketing and sales, or the marketing sales and the sales managers. I'd go to meetings with them, and they'd say, we need this, our customers need this. How come we don't have that? Or I would know enough about the businesses we were in. I'd go to meeting, I'd say, look, I think we can make a product like this. And is that something you think we could sell? And they do some market studies and get some feedback from their customers. And I would have the expertise and work with my chemists to make those products. And we'd make money once we started selling it to the customers. Well, I don't have one with me now, but if I did, I'd say, everybody, this is so important. The president of the company actually called me up and said, our competitor is making this product and we don't have that to sell. And what's this product? Miracle Super Bubbles. I think you've all seen it when you're a kid. You take the wand out and go, and the bubbles come out. And if we were in class in the lab today, I'd be doing that and having a lot of fun. And you would too, because you're going to be blowing bubbles today. Now, a couple of things. When you're doing experiments, and this is something a lot of chemists forget, you should only change one variable at a time between experiments. Because if you change two of them and it works, well, what made it work? You don't know. Or if it doesn't work, well, did they both make it not work or one? So you should only change one variable at a time. But at the same time, in industry, time is money, and you want to get a lot of results quickly. And that's where you use what's called design of experiment, DOE. I know how to do DOE. And this lab, I've done that, where we've done a number of fields. If you've been in the lab, you do a number of experiments and then get results and make your determination. Now, let's take a look at the lab. Come on. All right, everybody see developing competitive products on the screen? You see that on the screen now? Thank you. All right, now, today's lab deals with miracle super bubbles. And the first question is, what's a bubble? At this point, I blow a few more bubbles because Dr. White would be having fun blowing bubbles. And then on the whiteboard, I would do the following. What's a bubble? Well, inside a bubble is air. Outside the bubble is air. And this film is water plus other things. Well, something I need to tell you about air. Air is oxygen, nitrogen, and it's nonpolar. And water, which is mainly made up of what's the film of a bubble, you've learned, hopefully you know, is polar. And you know, like dissolves light. And what that means is things that are polar are soluble in polar things. Things that are nonpolar are soluble in nonpolar things. You mix two together and they're not going to be soluble. Well, how do you make a bubble? Well, you need something else there. Because if you take a beaker of clean water and one of those clean bubble blowing wands, you can spend the next 100 years trying to blow a bubble and you won't. Well, what do they put in there? They put in surfactants. And let me get to the real whiteboard because I need more space. And surfactants you learn, such as soap, have a nonpolar tail, polar head. That's a P. That's a better P. And if you put this in water, now you can blow bubbles. And if we look at our bubble again, I have water, but I now have my surfactants. And unlike when you're dealing with dirt, you'll form with the soap molecules in the surface of that film. The tail wants to get near the air, the head wants to stay in the water. And these are called linear micelles. And a bubble is really just a very special micelle, which you learned about in soap making, or how you get your hands clean. So in today's lab, you're going to be testing different solutions of surfactants. Now, the surfactants you'll test are, and let's look real quick at the lab. The first one is dishwashing soap, and I'll go through this in a little while. The second one is liquid hand soap. And the last one of these formulations is laundry detergent. I don't know about you, but the best one out in the market and has been for years is Dawn. In fact, a while ago, I picked up extra bottles because I'm hunkering down for the winter. So I've got enough liquid hand soap and Dawn to last through next fall, if not longer. But Dr. White believes in overkill. Now, what's the structure of Dawn soap? Well, if you look at the key ingredient, R here has 10 to 14 carbons. This is called the sulfonate anion. And if you notice, you have nonpolar tail, and this whole thing right here is your polar head. Now, there are other things in there, chemicals in Dawn, to make it work better. And I'll talk about a chemical that's in there called the foamer a little later. Now, the next one is your liquid hand soap as opposed to bar soap. Now, this up here is made from an alcohol of a fatty acid with sulfonic acid or sulfuric acid and made into sulfonate ester. This right here is called a sulfonate ester. Now, if you take that same alcohol and ethoxylate it, react it with ethylene oxide, which you've learned, you'll make an alcohol, which you can also react with sulfuric acid and make the sulfonate. And here, N is usually 3 to 5 moles of ethylene oxide. Isn't that amazing? And this is a little harsher on your hands, which are less, not harsher, it's a little better on your skin than this right up here. And here again, R is C10 to C14, 10, 12, or 14. Since R comes from natural products, it's going to be even number. And again, here you have a nonpolar tail, and a polar head. And the final one is laundry detergent, and I've been using for decades because I think it's one of the best, and that's what we got in the lab if we're in the lab. Now, laundry detergent is a little different in the structure, but it's still a nonpolar tail and a polar head. That's the worst benzene ring I've ever drawn. No, maybe not the worst. Oops. This is direct bond to the sulfur. And you know how to put a sulfuric acid group on there, and you can make it into the sulfonate. You know how to put an R group on a benzene. And this was developed at the end of World War II, and by the mid-1950s, it was established. And this also has a polar tail, and a polar head. All right, everybody got that down? If not, go back to the video. So let's look at the lab. What are you going to be doing? Now, before I do that, the question is, well, how can you tell if you got a good product? In industry, we call that, you have benchmarks. You know, in the old days, I guess, they put a mark on a bench. Is this high enough? No, that's just a joke. I don't know how it got its name, but anyways, a benchmark is, this is certain properties your competitor has, and you're trying to get as good as or better. Well, what can I do? Well, the school wasn't going to let me spend thousands, tens of thousands of dollars to buy equipment that measures surfactant and certain aspects of them. So how did I come up with something simple? Well, what are we doing? You're blowing bubbles. If you're a little kid, what's important about a bubble? One, you can blow it, and two, it lasts a long time. And that's something we can measure cheaply in the lab. And what I had students do was blow bubbles and measure how long before they either pop or hit the ground and pop. And at this point, I was telling students about proper etiquette in the lab. It's not polite to burst your neighbor's bubbles. I had some students who would do that. No, you can't. Two, it's not polite to blow bubbles at your neighbors or your lab partner. And three, most importantly, it's not polite to blow bubbles at Dr. White's head or any other part of my body. The other thing I'd warn is every once in a while, wipe up the floor. You're blowing bubbles because it'll get slippery. And let's go to the lab. And before I do that, what I came up with is that you would measure the average life of 5 bubbles. Now, you might have outliers, so you may have to blow 10 of them, but take the average. I also told students sometimes some of these formulas are really bad, and you can't even blow one bubble. So if you can't blow one bubble after 10 tries, put down 0 for the average bubble life. Now, in part A, you would be using the dishwashing soap as a surfactant. You make various solutions. A1 would be 2 milliliters of the dishwashing, 18 milliliters of water. A2, we've now put twice as much, double the concentration to see if the effective concentration has on the bubbles. Now, if you go to patent literature, and you might want to wonder, is there money involved in making these types of solutions? And the answer is yes, there is. How do I know that? Well, if you see patents, and patents can be found, the most useful site on the internet for Dr. White, besides Google search engine, is the United States Patent and Trade Office. Search for patents, and you can find patents are a way of protecting an idea of either a molecule or application of a molecule so no one else can use it for 20 years. Now, patents, first of all, it's $5,000 application fee to the government. Next, when you have lawyers write it, you're going to spend another $20,000 to $30,000 for lawyer fees, unless you have them in-house and you're paying their salaries, and it's still costing you money. Plus, you're going to pay someone like me to develop it. So if you're filing a patent, you're spending a lot of money. You expect to protect an idea that will make a lot of money. Well, it turns out there are a number of patents on these formulations. Now, once in a while, not all patents are true. So you got to keep an eye out for that, especially those from Russia. Russia, for many decades, to impress the leaders there, scientists publish all sorts of nonsense in patents. But anyways, a number of patents say you can get better, longer lasting bubbles by adding glycerin. That's because it helps hydrogen bond to the water in the bubble, because glycerin has 3 hydroxyl groups. Well, is that true or not? Well, I don't know. So we have this glycerin. We put 5 drops into the formulation of A1 and then doubled it, and also the surfactant in A2. And you test the bubbles. Finally, another source of hydroxyl groups for hydrogen bonding, cornstarch. And again, there are patents that say you add some cornstarch, and I'd make up a cornstarch solution that'd be in there, and you add 10 drops of that to an A2 solution. And so you have 5 formulations you test. Now, I've given you the data, what students would normally get. Now, if you notice at the top, it has competitive product. That's your benchmark. The competitive product averages 10 seconds for bubbles. And you've got to get as good as or better than, or it's not going to sell. And this is a standard way you'd write it up in a research book that was used for legal purposes. One of the things I always talk about, when you're in industry, you have your own lab books that are hardbound, and you have a carbon copy you can rip out, but there's one copy you can't. And at the bottom of each page, you have to have that count, you sign it and date it, and this is for legal reasons for patent rights, and you have someone else in your research group countersign it and date it. It's a pain in the butt, but it's important. And companies I've worked at, about once every couple of months, a lawyer will come by and go into a research group and say, "Can I see your notebooks?" If they're not up to date signed within a week, the manager gets in trouble, which I don't like getting yelled at. So every week I'd go around and check all my chemist lab books. Are you signed up? Are you up to date? And if they weren't, I'd yell at them, not bad, but I'd say, "Come on, you don't want to get us in trouble, do you?" I'd use Jewish guilt, make them feel bad, and it worked too. Dr. White can be sneaky when he wants to, and that's an important thing. All right, and we'll do the same thing for the liquid hand soap. Now, this is very thick and viscous, so instead of measuring a volume, we weigh it out. Think of if you were to measure out honey. How long would it take you to get honey out of a graduated cylinder? A long time, and you wouldn't get it all. Well, that's why we weigh it. And I'm assuming 2 grams is about the same as 2 milliliters. And it's a good assumption. And here we'll take B1, which is similar to A1, 2 grams of this, 18 parts of water. Here we'll have 4 grams or 4 parts, 16 parts of water milliliters. And we've effectively doubled the concentration. So it's similar to A1 and A2. And B3 is all of B1 with 5 drops of glycerin, similar to A3. And B4, except the different surfactant, is all of B2, which is the higher concentration of surfactants and a lot more glycerin. And finally, make another B2 and add 10 drops of cornstarch solution. And if you look at from here to here, they're the same experiments, even though in each grid you're changing variables, but between each part, you've changed a variable. So you're changing a lot, but in the realistic, this is called DOE. I'm really in each experiment only changing one variable, but I'm getting a lot of data quick. Now, part B was the liquid hand soap. And the last one would be part C, which is the laundry detergent all. And it's the same thing, C1. Now, all is less viscous, easier to measure in a graduated cylinder. So 2 milliliters of that, 18 milliliters water, 4 of that for C2, 16. You've doubled it. Notice how it's like part A and B, except you changed the surfactant. C3, you have all of C1, we're adding the glycerin, some, and C4, more surfactant, more glycerin. And finally, in C5, you make another C2, and then add 10 drops of cornstarch. And like these, I didn't show you here, all you do, you don't redo this, you copy the commercial over, but here's the data you would have generated from the average of 5 different measurements of bubbles. It's really fun watching students blow bubbles. And here, notice some of the formulations are not good. Now, one of the things a number of years ago, when I just had A, B, and C, a student came up to me and said, "Dr. White, can we use the chemicals we have out and make our own formulation?" I said, "That's a great idea." And the next semester, I incorporated in the lab, and I let students make their own formulation. And you can do that too. and you won't get any data, but you can put it down. And I'll be honest, the student formulations over the years, what they come up with, have been much better than the test ones I have. And it's amazing. About 2 years ago, and it'll probably never happen again in my lifetime, it was the perfect storm. Students had their own formulation, they blew a bubble, and it got up in the air in the room, and it lasted for almost 5 minutes. The whole class was watching it. It was amazing. 5 whole minutes for one bubble. That was a great formulation. Now, to make it real life, and I can't do it for you, when I was a manager, if somebody came to me, oh, it solved the problem, let's write the report and get it out. And I said, whoa, stop. I'm not putting my neck out on a chopping block for someone to find out you messed up or it's really not that good. You're going to show it to me right now that it works. And when the big boss is watching, now you're under pressure. By the way, that's happened to me when I was in industry. And do you wilt or do you stay up to that pressure? Well, how do I give students that same exam experience? And the way I did it was I said, each student pick a formulation and all you have to do is blow 2 bubbles for me when I'm watching. And it got hard because the pressure was on because the teacher is watching. And they always did, but it was funny to see them under pressure. And they got that experience being under pressure. Some of them it didn't bother, some. Oh, and I also warn students that when you do a little experiment, you're in a pair, sometimes one partner is so good at blowing bubbles and other is. I had one student, I don't know how, but inhaled and got some in her mouth. It tasted bad, I'll bet. Yeah, I can remember her, but it wasn't hazardous. And I'd give my initials here and I'd sign it. And then here are the questions. Now, before I let you go, I got to tell you a few things and pay attention. One, you've been conditioned that when you use a cleaning product like dishwasher soap or your hand soap, oh, look at the bubbles. That helps make it clean. No, the bubbles have no, you've been conditioned bubbles make it work. No, there are chemicals that are put in those products called foamers. Those are special type of surfactants that are mainly there to help make foam. Foam is a state type of bubble. Think about it. Now, many years ago, I was working at this one company, Unichem Chemical. I was the laboratory manager. I managed both quality control and research for North America. And the plant site where our labs were, I was also in charge because I was the senior scientist in the full site, all regulatory affairs. Boy, that was a headache and a half, but they paid me really well. And I mean, really well. We're talking 6-figure salary. But anyways, we had these 2 big waste treatment plant ponds that we put, and these are fatty chemicals in there, and we had colonies, microbes that ate them up, the chemicals before we dumped it into the Chicago sewer. And every 3 months on a surprise inspection, they'd set up a sampling machine and test our water. And if we didn't do stuff right, we could get fined $1 million up to. And that's another story for another day. But I got the company out of $1 million fine. But so one time I get a call from the plant manager, we got a problem. What? Come over to the one pond. Now each pond was about the size of a football field, about 20 feet deep. I figured there was about 1 million gallons of water in each one. A conservative guy. It was huge. And all of a sudden I go out to the plant to where this pond is, and there's a plant manager, and there's foam coming out the top, and it's going over the bank of the pond. And about 30 feet away is a fence and Racine Avenue in Chicago. If that foam hit Racine, we would get in big trouble. And next thing I knew, the president of the company, United States, was out there. Well, you're going to get rid of it, aren't you? And they're all looking at me, and my boss was out there and said, all right, I got to find a defoamer. There are molecules or surfactants that make foam, and they're molecules that destroy or inhibit foam. Those are called defoamers. I did some quick tests, and I realized the defoamer I needed to do this, because I had a lot of material, but this stuff is really powerful. They didn't have any nearby, and because of the fines we could have gotten hit, I had our purchasing agent have 4 drums. Each drum is 500 pounds, so that was 2,000 pounds of this chemical air shipped overnight in a special plane just for us from California to Chicago, and we dumped it in, knocked the foam down. And think about it, 4 drums, that's 55 gallons or 1,000 pounds roughly. It's only 200 gallons that you put into a couple million or million gallons, this strong stuff. So there's 2 types of molecules that are important. You should remember, there's those that cause foam, there's those that stop foam called defoamer. Now I have one more story, this is a good story. Should I cut it out of the video? Now I'll leave it in. When I was at another company, Borden Chemical, the managers there, when I joined the company as a manager, had a thing in the research department. They go to this local hole in the wall in Forest Park, Park Forest. And no, Forest Park. I always get too mixed up. By Harlem and Eisenhower, around that area. And we'd sit down Friday afternoon after work, get a couple of pictures, and have a few beers, and then complain about upper management, what idiots they are, or some of the people in our group, what idiots they were, and the problems they caused us. Or someone who did something good. Mostly it was about people who were idiots. Who, you know, I can't call them an idiot, but I can grouse about it to the other managers. Well, it turned out that owner of that small hole in the wall tavern, it was one of those with a few tables, a bar, no windows, and it was pretty murky and dark, but they'd been going there, had a special talent. When he served you a pitcher of beer, about this much was foam. And if you complained, you say, well, go somewhere else. Well, and I wish I could take credit for this, but another one of the managers knew surfactants as well as I did. And unbeknownst to all of us, he was really getting upset about the foam. Now, another thing I should tell you and teach you about is when it comes to chemicals, there are 2 types of chemicals. Those that are industrial grade and those that are food grade. And food grade, besides being ultra pure chemically, are biologically pure. No microbes or anything that you would consume and get sick from. Another thing is any chemical company that sells chemicals, which they do, has what's called a sample room. And a sample room is if you're a customer, or you could be a good customer, you call up the sales department and say, hey, could you give me a sample of this product of yours? I want to test it, see if we can use it to make a product for us. And companies, sure, if you're qualified, they'll send you anywhere from 4 ounces up to 5 gallons free. And in fact, one company, part of my job was to oversee the sample room too. And it was a very important part. Well, it turns out this manager called the company and got 4 ounces of food grade defoamer. Took a little plastic bottle, filled it there, squeeze bottle, kind of with a little eyedropper top, put it in his coat. We went there and he says, is the owner looking? No. And he pulled it out in an empty pitcher. He put about 20, 30 drops, swirled it around, coated the walls. Hey, we need a new pitcher. And if you've ever been to bars, you know how they have a soap sink, then a couple of rinse sinks, and they hang it up. Well, after 2 or 3 pitchers, all those were contaminated with defoamers. So that means all the pitchers were coated with defoamer. So when the owner tried to put a head on the beer pitcher, he couldn't. Well, we stayed longer that night and had a few more pitchers, and we were starting to laugh our heads off. Finally, that owner said, "Wait, you're scientists. What'd you do?" "We didn't do anything." We're laughing our heads off. And he said, "Get out of here, never come back." And we did. We found another place that didn't sell us foam. So don't forget, there are 2 types of chemicals, foamers and defoamers. With that, I went a little longer, but you got some good stories today to warm your Thanksgiving. Have a happy Thanksgiving, a safe Thanksgiving. I'm done for today. So are you. Gang is on. I'll see you on Monday. There's no office hour tonight because the school closes at 5. I had one last night. If you need something over the weekend, like you really need help, email me. I'll see if I can set something up. With that, be safe, be healthy. Enjoy your turkey or whatever else you're going to do. I'll see you on Monday.